Hello, everyone, and welcome to the Building Show webinar series. My name is Anthony Youssef, and I'm a Senior Program Manager with Forma Connect. I'll be your host for today's webinar, Supertalls in Toronto, Data, Challenges, and Opportunities. Today's webinar is in the lead up to the Building Show, Your Path to North America's Future Built Environment. I'd invite you to visit www.thebuildingshow.com to learn more about this year's event and to sign up for updates on registration launch. Today's webinar is in partnership with UrbanToronto. We'd like to extend our thanks to the UrbanToronto team for their contributed collaboration with us. And now I'd like to introduce UrbanToronto co-founder, Edward Skira.
Hello, everybody. I am Edward Skira, and I am co-founder and co-publisher of UrbanToronto. Welcome to the Supertalls in Toronto webinar. Let's talk about UrbanToronto a little bit. UrbanToronto began in 2002. We began as a discussion forum. As you can see here, we have about 47,000 registered forum members currently. They can comment, they can post. There's a lot of banter that goes on there. We have somewhere in the range of 600,000 photos in our forum that have been uploaded by our forum members over the years. So we have an amazing historical record going back to 2002 when the site began. We also have a news page. We do 5 to 6 stories a day. We have maybe 30,000 articles over the last 20 odd years. So there's a lot of information and a lot of stuff that we do, tracking development across the Toronto region. And we have data. We have a product called UT Pro, which I'll talk about shortly, that covers all development across the entire region. A little bit to fit in with the theme today. So when we began UrbanToronto back in 2002, there were 7 buildings over 150 meters or 500 feet in Toronto at that time. Those were built buildings. In 2024, from our UT Pro database, we are looking at 328 projects. Now, these are built, under construction, and proposed, but the number is huge. Over 25 years, essentially, Toronto has obviously soared upwards, and this includes the entire region that we're talking about. On the left, you can see a number of the buildings by height that are in our database currently, and there are 7 that are at super tall status or higher, 2 of which are currently under construction, Pinnacle 1 Yonge and what is now called 1 Bloor East, or 1 Bloor West, apologies. 1 Bloor West will be a super tall anytime now, with Pinnacle coming up behind. So there are, in 2002, there were 0 super talls. Today we have 2 under construction, 5 others proposed. And I'm sure over the next decade or and longer, we will be seeing a lot more of these. This is our homepage. As I indicated, we do 5 to 6 stories a day. They're all development focused. UrbanToronto averages about 300,000 unique visitors per month. 1/3 of those are in the business one way or the other: developers, planners, suppliers, brokers, people like yourselves that are listening in. We also do about 2 million page views per month, and we have about 160,000 followers on our social media, LinkedIn, X, and so forth. Here is the forum. We have a number of different sections. The building one is the most important one. Every single project in our database, over 5,700 currently, have their own thread where people can specifically discuss that specific project. We have, as I indicated, 5,700 plus projects. Our data team is adding new people or new projects every day. We track development from the moment there's an application at any of the municipalities that we are tracking, all through the approval process, through construction, and through completion. And we track all asset classes, so residential and all forms of residential, whether it's condo, rental, and so forth, industrial, office, and so forth. So everything from a small townhouse development all the way to CIBC Square are in here. This is our coverage area geographically, essentially Bowmanville on the east, Barrie on the north, Kitchener-Waterloo on the west, and Niagara on the south. Key statistics, I already went through all of these. UT Pro is where all our data is stored, and that is an important product for us. These numbers are a little out of date, but I already mentioned what they are. A key element of UT Pro, it is a subscription service that allows our subscribers the ability to access all 5,700 projects, all 5,000 companies. On the public side of Urban Toronto, we display 10 data points for each project. We actually track 144 data points for each project. So there is a wealth of information, and UT Pro offers tools, sophisticated tools that will allow you to download information via spreadsheet and do a lot of other types of analysis that will help you get the information you like. This is what UT Pro looks like when you log in. It looks like the regular site, except that there's a logo here that is UT Pro, and there is a bunch of different sections. The map, you can see here there's a spreadsheet, so you can pull specific areas. You can draw a polygon or a circle on the map and export it quite easily into Excel or Google Sheets. Streams is an important element of what we do. We have 3 lists. We have new projects. Every new project, as we add them in, our clients get to see them in real time. Project updates, every update we make to a specific project, the height went from a certain height to a different one, a new principle was added, whatever it is, you'll be able to track that in UT Pro. And finally, applications. So this is a stream that comes from the City of Toronto. It is basically tracking every single application to the City of Toronto, whether it's planning, whether it's COA, whether SPA, OPA, rezoning, and so forth. And you can filter by planning, COA, or TLAB. There is a ton of information here. We have, like I said, about 5,000 companies, over 5,000 companies in our database. You get full access to them in UT Pro. You can select and filter by category. You can put in a specific company name in here and just look at their projects. So there is a really important way to sort of follow what's happening. The reports is a very integral part of UT Pro. It allows you to look at 5,000 companies, 5,700 projects, 144 data points, and slice and dice the data however you like into spreadsheet form. We have dashboards. This is one that's available on the public side, on both sides. Pro actually has additional dashboards just for members. But this is an overview of development across the entire region by number of projects, number of units, cranes, and so forth. So that is what UT Pro offers. There are 3 types of clients for UT Pro. People who are interested in planning, so developers, planners, and so forth. You want to know what's happening within a kilometer of your building or your land. You want to know about what everybody else is offering or doing. Very easy to do. Number 2 is suppliers. We have a lot of suppliers signed up. They're looking for leads. They want to know about the projects as soon as possible. And because we are tracking from the moment there's an application, our subscribers get early access to what is happening. And finally, on the map, I didn't talk about it before, but we have a bunch of subscribers who use it to visualize population growth, where the population is headed. We can draw a circle around a certain intersection. You can pull how many units are proposed, and from there you can extrapolate and figure out exactly how many projects or how many people will be moving into the area. So we have a major bank that uses it to figure out where to put their branch network. We have a major grocery store chain, same idea for their stores. So anybody who's looking forward in terms of growth, government, retail, school boards, transportation, UT Pro is your product. So that is Urban Toronto and UT Pro in a nutshell. If anybody has information or wants to know more about any of this, you can email me, edward@urbantoronto.ca, edward@urbantoronto.ca, and I will get back to you and we can schedule a meeting. I am now going to hand off the presentation to Craig. Thank you.
It was a really great seminar, but we thought we would like to bring it to a larger audience. And I feel even luckier today because being able to schedule a lot of high-placed people, again, the second time is pretty rare. So without further ado, let's dig in. We're going to go through the buildings in sort of a chronological order as to how they are when they started, and let's talk about One Bloor West first. Formerly known as the One, One Bloor West is now being developed, constructed, and sales managed by Tridel. The building was originally approved as an 85-story, 308.6 meter tall super tall, the first building in Canada to be approved over 300 meters, and was subsequently approved at 328.4 meters tall when the previous developer saw ways to amortize costs over a larger building. And frankly, there was also a bit of a battle going on between them and Pinnacle One Young as to which of the projects would be the tallest. Following receivership, though, the Tridel has decided to stick with the original 308.6 meter tall plan. The building is now about 295 meters tall. Earl can correct me if I'm a little off on that, as work is just beginning above its 85th story on the steel framing for its crown, within which will be a tuned mass damper that will decrease the building's sway in windy conditions. It's something that shows up in all of these tall buildings. One Bloor West has consistently been one of the top two most popular threads and database files on Urban Toronto for more than a few years now, telling us all about the architectural challenges on One Bloor West is Earl Mark, partner at Toronto's Core Architects, who have worked hand in hand with Foster and Partners to make this very complex building a reality. Earl Mark graduated from McGill University in 1999, and in the following year, he began his career at Core. He has been an active contributor to the growth of the office and has helped deliver many projects with a high level of excellence from both design and documentation perspective that has become synonymous with Core. Earl has played a significant role in projects that have helped reshape neighborhoods such as the Byward Market and Centertown in Ottawa, Allenbury Gardens in Toronto, and projects in larger urban environments such as the Dubai Marina. Currently, Earl is involved with the delivery of Canada's first approved supertall, One Bloor West. Take it away, Earl.
Okay, thank you very much, Craig. Hi everyone. My name is Earl Mark. I'm a partner at Core Architects and very excited to be here to talk to you about the challenges of designing a super tall building, particularly in the context of One Bloor West. This is a project that our office has been involved with for over 10 years and is pretty near and dear to some of our hearts here. We actually gave this presentation, as was mentioned earlier, back in 2024 in December at the building show. And it was a pretty rewarding experience overall for us. One, we got to share the stage with our friends Jody and Nadine from HPA, as well as Abel from Adamson Architects or Adamson Associates. And what we started hearing when we got feedback after the presentation was over is that we were told we managed to give some information that hadn't already been covered in the thousands of pages and posts on the Urban Toronto forums. So when we were asked to give this encore presentation, we were more than happy to do so to reach a larger audience. So special thanks to Craig and Ed Skira for inviting us to do this presentation again, and to Anthony Youssef of Informa Connect for organizing today's seminar. And without much ado, here we go. So Core Architects, we're an architectural design firm that's been in practice for over the past 30 years. During this time, we've developed a number of strong partnerships with developers, consultants, and members of the construction industry. We are a firm that specializes in a number of sectors, having experience in the retail, interior design, and commercial sectors. But really where we've made a name for ourselves is in the multi-residential sector. During this time, having delivered over 200 million square feet of residential GFA and having completed 200 projects in the GTA and abroad. Just a quick couple of examples of our work going left to right on the screen. The first is 210 Bloor, a project that, while it's still in the drawing boards, has won a number of international design awards, the most recent with World Architecture News. In the middle, we have 48 University. This was originally an 18-story brutalist office building at the corner of University in Dundas, where we were asked to add 35 stories of residential above the existing building, excavate an extra 2 levels of below-grade parking underneath the existing parking, all while keeping the office occupied during the entire course of construction. And then last on the right is M-City, M1 and M2, buildings where capped out at 61 stories in height did make us sensitive to some of the challenges of building tall buildings. But today's conversation is about supertalls and what makes these projects specifically challenging. And it was a question that we asked ourselves at the end of last year, understanding that the goal of designing any building is fundamentally the same, where you're trying to create an environment that's safe for its inhabitants, keeps them sheltered from the elements, and maybe does so with a particular architectural language and style. But what we realized is that when you start designing a building to that 300-meter mark, I guess the threshold for super tall status, you start understanding that some of the factors that you normally wouldn't have to consider at lower heights become magnified in specific risk issues for the project and need specific solutions for them. So while it's a question of dealing with stack effect or the dynamic forces of wind acting on the building, they're all things that need to be addressed. So we'll get to that a little bit later in the presentation, but firstly, we'd like to have a small discussion about the project site, its context, and its program, because these are all elements that shape the project story. So this is our site at the intersection of Yonge and Bloor. This is maybe arguably one of the busiest intersections in the city, if not the country, and our site is the red outline area in the southwest corner. At the confluence of the city's two main transportation lines. It's a fairly desirable property from a commercial perspective, anchoring the east end of the Mink Mile, our city's high-end retail district, as well as being close to some established neighborhoods such as the Annex, Yorkville, and Rosedale. This is our site as it existed in 2014, and this was the year that ownership of the site changed hands from the Stollery's family to our client, who asked CORE to undertake a number of feasibility studies to see what could actually be achieved on the site itself. It immediately became apparent to the client what the significance of the site could be for the city, but also for the city skyline. And at this point, the client commissioned a small competition inviting Robert A.M. Stern, Renzo Piano, and Foster and Partners to deliver their vision for the site. This competition was won by Foster and Partners, with Core Architects retained as architect of record. And this is where our story really starts, and the story starts in London. So here we are in Foster and Partners offices in London. I don't think F&P really needs any introduction to the audience here today. They're a world-renowned architecture firm and really a juggernaut when it comes down to work. When they started the design for this project, they produced countless numbers of drawings, sketches, diagrams, and models to study what this site could be. The evolution of design took the course of the next 2 years, informed by a series of workshops, 5 in total, run by Oren Tamir and James Parak at the city, without whom and their support this project wouldn't have been realized. But also at this time, and just as importantly, RJC, our structural engineer, and RWI, our wind consultants, were also retained to help inform the building and optimize the shape of the structure from the rectangular shapes that you can see on the table in the middle at the bottom of the screen to the 30 by 30 square floor plate that's being constructed on the site today. It's probably no secret at this point that the building was purpose-built around a singular ground floor retail tenant. This particular electronics giant had a couple of simple asks. They wanted the project to have a retail space that was roughly the same size as the tower shape above, over 40 feet or 13 meters high, and they didn't want any columns falling into their retail space at all. And so this is effectively where the first challenge of the project set itself in, where you would expect to see the tower core consisting of its elevators and its stairs coming crashing down through the ground floor and anchoring down to the foundations below. Here we were required to stop that tower core at level 5, where it couldn't act as a stabilizing mass, and the project team was forced to figure out how to deal with the combined weight of approximately 4,000 Sherman tanks worth of concrete, glass, and steel, and have this hovering over the commercial floors below. From a vertical transportation perspective, the solution was pretty straightforward. Coming in from the main lobby, a dedicated group of elevators was added on the west core of the building, 3 elevators taking residents up from ground to their sky lobby on level 6, and then patrons to the hotel and the associated commercial floors up to their connecting points at levels 5, 4, and 3, respectively. From a structural perspective, the solution was also pretty simple. 8 mega columns were introduced, 2 per side of the building to support the tower perimeter. The term mega column, maybe not the most original, but probably one that's entirely accurate. These are columns that are 2 meters wide by 1.8 meters deep, minus the chamfered corners that you can see in the image on the right. And they're composite steel and concrete structures with I-beams or W sections, approximately 550 deep by 450 wide and 115 millimeter flanges. Or for those of you that are more comfortable in imperial, just imagine these columns being just under 7 feet wide by 6 feet deep, with 22 by 18-inch steel structures in them, 4.5 inches thick. So some fairly significant structural members here. This image on the right was taken sometime in 2020. So here you can see the mega columns as they're being erected on the ground floor. And the crazy thing here is that you can barely make out the embedded steel columns inside those mega columns because of the reinforcing steel cages needed to ensure that the columns themselves wouldn't be suspect to any buckling, twisting, or bending while it's supporting the envelope and the structure above. And then finally, Foster and Partners took the idea of having a column-free retail space and translated this conceptually to the residential towers, where aside from the mega columns, the only other structure that would be visually experienced by the residents would be 4 columns, 1 in each corner of the tower, spanning 5 out of every group of 6 floors, supported in turn by diagonal steel struts, resulting in this sort of belt and suspenders type structure that you can see on the diagram to the left. And in our opinion, resulting in an elegant tower that's roughly 305.8 meters tall, 85 stories in height, with 5 levels of below grade program, and over 1 million gross square feet of gross construction area. So one of the defining features of the buildings were these cutouts shown in the diagram in blue to the left. These cutouts served a number of functions. One, they helped break up the mass of the tower, providing visual interest in terms of its form and materiality at these breaks. And these cutouts were meant to effectively house our mid-level mechanical plants. And so if you think about what's happening here physically, it's next to impossible to pump water and other services 300 meters into the air and back down again. So these mid-level mechanical plants were required to serve the various parts of the program that they're associated with. This also helped organize our tower into its various components, with the commercial floors from ground to level 16, banks of 18 stories each of low-rise, mid-rise, high-rise units, and then finally the penthouse and the tower crown at the top. And the mid-level mechanical plants also allowed for partial occupancy of the tower to occur, meaning that we could occupy the lower floors, being the commercial and low-rise units, while the rest of the building was being constructed above. Maybe more importantly, what these mid-level mechanical breaks helped do was effectively sort of confuse the wind. And so what happened here was, with input from RWI, the corners of the mid-level mechanical floors were severely chamfered and cut back. And what this allows the building to do is that while the wind speeds wrap around the building, the wind actually gets confused and it starts to swirl around the corners, effectively slowing down the velocity of the wind and the forces acting on the building. And if we didn't do this to optimize the building shape, we would have ended up having a tower structure that was larger than what we had described previously. So on the video to the right, we're here in RWI's wind tunnel in Guelph. And so the smoke pan, as you can see it moving up and down the tower, represents the motion of air and the velocity of air it moves around the building. And it's really subtle, but when you see that pen pass the mid-level mechanical brake, you can see the smoke really dissipates, simulating the change in velocity of the air as it acts on the building. Finally, at the top of the tower, we added a TMD, or a tune mass damper, shown in the blue box at the tower crown. And the idea here is really this, is if you think about the fact that the building is really this big sail, and you have wind blowing against it and higher wind speeds at the top of the tower, and this acting as a really big cantilever arm, the wind will actually make the building move up to 455 millimeters in each direction, or almost up to a meter in total as this building moves back and forth. And if we didn't have any means to mitigate this motion and acceleration, we would have a number of negative effects on the building. Namely, one, it certainly wouldn't be comfortable for the residents at the top of the building and on those floors, but also the motion of the building would cause undue and premature material fatigue on the building systems, such as the elevators and their rails, plumbing through the building, and maybe more critically, the building envelope, where as the components start moving and the seals start breaking, you could end up having leaks within the building itself. And so with any tall building, once you start reaching the 40-story mark, you do need to think of some form of dampening, whether or not it's a passive system such as a slosh damper or an active system such as a TMD. At our building height at 85 stories, the TMD was absolutely necessary. So the TMD could maybe be described as a mechanical system with a mass that's being calibrated to move out of phase with the building to dissipate the energies acting on it. Or in really simple terms, it's just a heavy mass that swings like a pendulum. In our particular case, we have 350 metric tons of steel at the top of the building that's guided by a number of pistons, which will allow this mass to move in the opposite direction that the building is moving in, slowing down the acceleration and mitigating the negative effects of the building acceleration as it would otherwise be moving. So we talked about stack effect and the negative effects that stack effect could possibly have in the building. So stack effect could be basically thought of as the movement or displacement of large volumes of air due to the temperature differential inside and outside of the building, and having this air move through the building. So I try to think of it not as this idea that warm air rises, but more of this concept that, particularly in the winter months, cold air is heavier and more dense than warm air. And what this air tends to do is it tends to push itself down in the atmosphere and wants to enter the building through its openings, and whether or not it's through the doors, through air intake shafts, or through the garage openings, it pushes itself into the building and then displaces warm air, which then moves up the vertical shafts of the building, being the elevators, the stairs, and the garbage chutes. And so this stack effect needs to be mitigated. And I'm sure a lot of you understand what some of these effects are because you've experienced them before in the past, where you've had doors which have been really difficult to open or slam shut after they're closed. But what the stack effect will also do is it will cause some of the building systems to fail, where elevator doors might fail to open because of pressures acting against them. Or you might have areas where you're expecting to get tempered air heating or cooling into certain areas of the building, and that air gets displaced, resulting in uncomfortable rooms within the building itself. And so what we're trying to do is figure out a way to limit the motion of air in the building. And so the diagram that you can see on the right-hand side, this is an axonometric taken on level 6 of our building, where you can see the arrows indicating the direction of air movement through the building, and the size of the arrows representing magnitude. So in this particular case, you can see where we're expecting air to come in through the exterior amenity terrace, through the doors, as well from the elevators on the west core of the building to the tower, making its way to the elevator core and the stairs, and making it up the building itself. So to limit this displacement or motion of air, we've introduced simply vestibules or airlocks in the building, shown in the regions in orange, simply by providing a series of doors with high quality seal packages around the perimeter. What we're attempting to do here is limit the amount of air that could pass through the exterior into the building core, and thus limiting the pressures that would be affecting the stairs and the elevators and limiting the stack effect on the building. In a similar vein with the elevator cores and stack effect being caused by temperature differential, here we are showing a diagram illustrating air cooling being provided to the elevators themselves, reducing the temperature in the elevators to match closer to the outside air temperatures, reducing the stack effect through these vertical systems. And as well, where we have our exit stairs, on a similar sort of notion, we've introduced voluntary stair pressurization in the tower, blowing air into the stairs almost like inflating a balloon, thus preventing air to move into the stairs and causing the negative effects of stack effect taller in the building. Okay, so in the interest of time, I'm going to have to talk faster than I already have to zip through a number of slides here. Just really simply, ice and snow, it's a definite cause for concern for some of the taller towers. We'd have to find ways to prevent snow and ice from being able to accrete, form on the tower surfaces and fall to the pedestrians below, creating some risk areas. So here we simply have an image of our front entrance canopy, where the horizontal surfaces of the canopy and the gutters have been provided with snow melting to allow for water to be collected and run back into the building as to not form icicles on the canopy edge, falling down to the main entrances below. On a similar vein where we have some larger horizontal surfaces and the slopes are mandated to slope towards the street, snow angles have been provided to prevent any snow and ice forming on these surfaces from sliding off, protecting occupants along Yonge Street. At our mid-level mechanical floors, the same snow shelves have been added, but here, maybe more importantly, the geometry of the building has been highlighted where all of the angles of the horogrids and diagrids have been, I guess, profiled to have an angle greater than 45 degrees to ensure that snow and ice are unable to form onto these surfaces. And the tower crown, again, the same sort of gutter structure or concept is being provided to ensure that any snow and ice on the hashtag shape of the roof melts and diverts back into the TMD roof without causing any risk to anyone below. Our tower envelope, as you can probably imagine, is one that's entirely custom, and it's a system that underwent 5 years of research, development, and testing. So these images are taken in Buffalo, where full-scale mock-ups were created, so that way the project team could understand if we were achieving the materiality, geometry, and the effect that Foster & Partners was looking for in the building. Lighting studies were also done at night to see whether or not the patterning on the surfaces were what F&P was expecting, with the lighting ultimately decided to be at the mid-level mechanical floors or the tower crown. With the manufacturing of the curtain wall system being in Asia, we were up in Shanghai to witness a performance mock-up where a 4-story full-size basically mock-up of the building was created with a pressurized chamber that you can walk inside. Here there was an array of water jets and a jet propeller basically blowing air and wind against the building to see if we can simulate the atmospheric conditions that the project would be, I guess, subjected to. And it was an interesting experience to be inside the chamber while the whole project team sort of scurried around looking to see if there were any leaks in the system. Ultimately, successful testing as we are clad up to level 61 on site today. The retail envelope, also a system that was bespoke with 2 years of research and development occurring for the retail glass. Again, visual mock-ups done with all members of the project team, where we're looking at the envelope without finishes and with finishes. And just keep in mind that this mock-up is probably about a third of the height that exists in real life. But these are some fairly definite large panes of glass. They're roughly 2.4 meters wide by 11.5 meters high in terms of their visual section, over 14,000 pounds, which would require some fairly specialized tool to get this glass into place, but ultimately resulting in a ground floor retail space that's truly spectacular and worth the effort of the 962 pages of shop drawings that we had to review for this system alone. And then lastly, just to touch on this heritage component, we had a property at 774, 776 Yonge that needed to be preserved up to a depth of 5.5 meters. So here we are suspending this volume in the air as we're digging 20 meters below in our parking garage. This was a photo taken at the underside of this structure. It was the only picture I took, and I never went back to stand underneath this building for the entire course of any of the reviews. So where are we now? I'm happy to say that construction has reached the 84th of 85 floors, so soon to top off. Cladding up to level 61, the Heritage and New Yonge Street facades complete, as well as the ground floor retail glass. And we're certainly happy to be working with a dedicated team from Tridel, who is really knowledgeable in construction, and to be able to work with some really skilled and knowledgeable trades, and looking forward to seeing this building complete in 2028. Thanks very much, everyone.
Thanks very much, Earl. If anyone has any questions that occurred during Earl's presentation at the end of the webinar today, we will be taking what we have time to handle. You'll see a spot on your windows where you can write in questions. In the meantime, let's move on to Sky Tower at Pinnacle 1 Yonge. Sky Tower at the foot of Yonge Street is the second skyscraper rising at Pinnacle International's Pinnacle 1 Yonge project. The complex was originally approved as 3 mostly residential towers of 65, 80, and 95 stories on the north half of the lot that is anchored by the Toronto Star building, which won't be around for much longer. With the 65-story first phase, known as the Prestige, now complete and occupied. The 95-story second phase, Sky Tower, was initially approved at 307 meters, but through subsequent revisions is now approved at 106 stories and 354 meters tall, easily making it the tallest building under construction in Canada, or even proposed. Sky Tower is currently about 74 stories tall and is growing another floor taller every week, while the project has had comparatively simple path to realization development-wise, and its engineering is not as avant-garde as One Bloor West in one way. The design of a 354-meter tall building, nevertheless, has to overcome challenges that the more everyday 50-story tower simply doesn't face. To speak about it today are 2 of its lead designers, each with their own areas of expertise. Jody Buck, associate partner at Hariri Pontorini Architects, is an RAIC member with over 20 years of experience, has been an integral part of Hariri Pontorini Architects since 2005. Jody's technical and design expertise takes projects from schematic design and translates them into architectural drawing sets. Jody boasts an impressive portfolio of large-scale master plans and high-rise buildings, including the transformative Canada Square project at Yonge and Eglinton, and Pinnacle 1 Yonge at the Toronto waterfront that features one of Canada's first supertalls. Nadine Elgazar, associate and senior project architect at Hariri Pontorini Architects, is an accomplished architect and associate at HPA, specializing in mixed-use and multi-unit residential projects with an increasing focus on super-tall buildings. Along with Pinnacle 1 Yonge, Nadine's portfolio includes 19 Duncan and Artists Alley, both recently, 19 Duncan now complete and Artists Alley completing in the city at the moment. I'll pass it off to Jody and Nadine.
Thank you, Craig, and good afternoon, everyone. My name is Jody Buck. I am an associate partner at Herrera Pontorini, and as Craig mentioned, I'm here with my colleague, Nadine Algazar, who's associate at the firm. And we'd like to thank UrbanToronto for inviting us here today to present the Sky Tower project. HPA was founded in 1994 by David Pontorini and Seamak Herrera. We are a 130-person national firm with projects spanning the country and internationally. HPA operates in an open studio environment that fosters a collaborative approach to design and the sharing of ideas. In addition to drawing and modeling, we also use a wide variety of in-house creative tools such as renderings and physical models to solve design challenges. HPA is committed to creating architecture that integrates into the existing urban fabric and improves the quality of urban life. And here are a few examples of our projects which span the various sectors and scales. Our firm blends contemporary design principles with a deep understanding of context, materials, and craftsmanship. HBA has been working with Pinnacle International, who are the developer of Wanyang, for the past 17 years, and we have collaborated on projects such as the Pinnacle on Adelaide and PJ Condos. What is unique about Pinnacle is that they are a self-performing developer and they act as both client and general contractor on all their projects. The benefit is that consultants get decisions made quickly and projects are built more efficiently. Our work with Pinnacle on the Wanyang site has evolved over the past 12 years, and this is a common theme across all the projects being presented today. The process from inception to completion is lengthy and complex. These landmark tall buildings need to be designed holistically and with a strong sense of civic responsibility. My presentation this afternoon will go through a brief overview of the evolution of the overall Wanyang project, and Nadine will be discussing the details of phase 2, which has now been newly approved at 106 stories. The Wanyang site is located on former industrial waterfront landfill at the foot of one of Toronto's most significant roads. The site serves as a gateway to the eastern waterfront neighborhood and the city core to the north, providing an excellent backdrop for a site capable of supporting a landmark tall building. The project was initially developed in parallel with the city's Lower Yonge precinct plan. Through a series of workshops and community consultation, the project's progression reflects a responsive approach to urban planning and public engagement. The design has also undergone several rounds of review by both the Toronto Design Review Panel and also the Waterfront Design Review Panel. During the initial schematic design stage, our site plan went through various iterations, but always with a focus on connectivity, pedestrian access, and public spaces. These are some of the earlier versions of site plans in which we explored different networks of mid-block connections. In addition, throughout the evolution of the project, we continued to evaluate how the massing impacted both the immediate neighborhood context and the wider city context. We studied tower placement and tower spacing through sketches such as the ones on the screen. We also did skyline studies on where to place the tower height. And our office did many physical massing studies. We also have a citywide site model located in our office, which we use to further evaluate the massing. In 2018, the 9-hectare Lower Yonge precinct plan was passed and our site established its current design. The precinct, once completed, is anticipated to be a high-density, sustainable community with a range of housing options and community services. Some key features of the Lower Yonge precinct are a central park, located between Freeland and Cooper Street. The neighborhood will be complemented by widened landscape streets along both Yonge Street and Queens Quay, and the plaza at the northwest corner of the site. Mid-block pedestrian pathways will weave through the site to further enhance the public realm. and a public art strategy has also been developed for the precinct. The One Yonge site itself has been divided into 2 parcels in 5 phases. The north and south parcel are divided by an extension to Harbor Street, which will be called Down Street. The north parcel has 3 residential towers, phases 1 to 3, and the south parcel has 2 office buildings, phases 4, 5, and the Toronto Star building. The program of the site features residential lobbies in that pink color, which have been located away from the corners and to create more private front doors. The hotel lobbies in the yellow color have been located on Main Street corners. Retail in the orange color wraps around a podium to animate the street edges. Affordable housing in the purple has been situated on the quieter Freeland Street. And office in the blue is located on the south parcel. The community center marks the corner of phase 1. Here on the left is a programmatic 3D axonometric diagram, and on the right is a 3D massing of the phasing of the project. Some statistics of the north parcel site is overall we're sitting at over 2.8 million square feet with 2,500 residential units. And in phase 2, we're above 1.18 million square feet of GFA and 958 residential units. The One Yonge project and precinct were envisioned as a complete community. Although still a long way from completion, we are seeing parts of this vision come to fruition through our phase 1 project. The One Yonge Community Center, which opened last fall, provides public recreation spaces. Additionally, the building offers a mix of housing options, including 100 affordable housing units located in the podium. And this is just some photos of the community center. As the remaining phases are completed, we will see the emergence of open spaces for public access, widened walkable sidewalks, and dedicated bike lanes. The cascading podium designs of the development will feature a series of residential and hotel terraces, encouraging a visual engagement between the public and private realms. As Toronto's population continues to grow, so does the demand for housing in prime locations like One Yonge. The trend of super tall buildings has become increasingly common in North American cities, and accordingly, Pinnacle approached HPA in 2021 with a proposal to raise the heights of both phases 2 and 3. The phase 2 project had already started construction in early 2021, so the additional height had to work within certain design constraints. Our structural and wind engineers evaluated how the additional height could be supported without requiring a complete design overhaul. Through a series of structural modifications, including lengthened shear walls, we were able to successfully accommodate 106 stories for phase 2 and 92 stories for phase 3. These changes required us to reimagine some key aspects of our original design, which included removing the tapered bottom of the tower. By 2021, we were witnessing the success of our phase 1 project as construction was well underway for that tower. With its distinctive twisting and torquing geometry, we decided to carry elements of this design language into phases 2 and 3 to create a cohesive family of buildings. We chose to use a consistent material palette and architectural language across all 3 buildings, while ensuring each building maintains its own unique identity through distinctive features. Phase 2 features prominent vertical fins to emphasize its height and verticality, with buttress balconies that seamlessly merge the tower with the podium. And wide, expansive, curved corner glazing fosters a connection between interior program and the surrounding community. At the ground, a continuous glass canopy will wrap around the podium, creating a more intimate scale while providing weather protection. The entrance to the hotel and residential buildings have been highlighted with a contrasting black stone facade. The crown of our building will be lit up to mark its place in the skyline at night. And as we have done throughout this project, the additional height prompted us to reassess the building within its immediate context and its relationship to the city skyline. The City of Toronto also asked us to review the relationship with the CN Tower, which we did through this skyline rendering, and also this diagram that notes the height metrics of our tower in relation to the CN Tower. We also did a view from the CN Tower observation deck looking towards the site. Lastly, I'm going to end my part of the presentation with a series of renderings we've done of our site within the city. And now I'm going to hand it over to Nadine to continue.
Thank you, Jody, and thank you to the Urban Toronto for the opportunity to speak today about Pinnacle Sky Tower. I'm going to walk through some of the distinguishing design features of Sky Tower and how we've worked to bring them to fruition in their built form, as well as some unique considerations we faced in designing a supertall. Sky Tower is a truly mixed-use program as envisioned by Pinnacle. It features 12 levels of hotel with event spaces, restaurants and bars, ground floor retail units on Yonge and Down Street, 93 stories of residential tower, and a rooftop amenity for a total of 106 stories. Each of the architectural zones was articulated by feature elements on the facade. The podium slab accentuation highlighting the terracing at the base of the building, the podium and balcony frit using similar language as prestige, the feature balconies that buttress the corners of the podium back to the tower, the vertical fins that enhance and elongate the height of the tower, and a tapered facade at the top of the building. Each of these unique elements came with their own detailing challenges. In order to ensure the detailing was commensurate with the monumentality of the project, we embarked on a design assist with BV Glazing with the support of Pinnacle's team to help us actualize the design elements in their built form. Podium slab articulation was achieved by applying a metal panel profile into the curtain wall system at the face of slab. The flat panel above the profile creates an interior sill on floor levels and a parapet on terrace levels. The guardrail extends out of the curtain wall, a signature detail that maintains the continuity of the detailing to the parapet. We studied how the profile could curve at building corners, taper and merge at transition locations, how it could morph its shape, flattening towards the facade, then extruding back out away from the facade. We studied how the flat panel above could increase and decrease in height and where to position the stack joint for the most flexibility. BV Glazing took that back to their shop and generated full-scale mock-ups to try out some of these shape changes, joints, and detailing. And in collaboration with our teams in Pinnacle, we landed on a final detail. We went through a similar process for the 8 vertical metal fins accentuating the corners of the tower. We proposed a size of fin based on scale and prominence. Due to the standard size of aluminum sheets, the sizes we had proposed would result in waste material, decreasing project efficiency. So we developed a solution that added discrete seams on the sides of the panel. This maintained the prominence of the feature while generating less waste material. We ended up with a roughly 1 meter wide by ½ meter deep fin with no seams on the visible corners and with guides at the stack joints to ensure perfect alignment between panels. BV Glazing went back to their facilities and generated a full-scale mock-up to test out the profile, construction, reinforcement, seaming before putting these into production, and we've been quite pleased with the results we're seeing on site. The corner feature balconies where the podium transitions to the tower required extensive modeling to establish the exact shape of the fins as they travel from the face of the podium towards the face of the tower. We've integrated a flat panel on the tower facade that follows roughly the same vertical path as the fin receding back towards it. And the two elements come together over a 10-story span. We also needed to figure out how to drain these balconies, as the typical approach of sloping off the edge would be a challenge with the metal panel above and below the slabs. We considered separating the panels to allow for water to drip down between the seams, but the team was concerned about the longevity of the aluminum with this approach. So instead, we decided to backslope and scupper down from one level to the next onto the unoccupied area of the balcony below, all the way down to the terrace on level 13. We worked with BV Glazing to fine-tune the assembly and structure of these slab covers, and our teams generated the detailing shown here, complete with drip edges and weep holes to allow water that does get on and into panels to find its path out and down to drains. When it came to the structure of the balconies, the increasing depth of the cantilevers required additional structural support. So the obvious place to hide that structure was inside the buttresses. We studied the best size and shape for the column as it traveled back to the building and segmented the concrete to simplify the forming. Pinnacle in their formwork trade suggested simplification of the shape of the column and segmentation of the angling of the columns for site feasibility. The concrete was designed to angle independently of the angle of the vertical fins, which was challenging since the joints in the fins aligned with curtain wall stack joints, while the columns ran slab to slab, a difference of about 400 millimeters or 18 inches in height. Here are some progress images from the site, with the structural columns without cladding and with some cladding installed around the columns. The fin cladding hasn't been installed yet, but we're looking forward to seeing that come together. In terms of the tower design, we worked collaboratively to iron out some of the more challenging details and transitions, including these corners where the initial proposal was to transition between curtain wall and window wall at the corner. However, with the challenges of differential movement and slab edge placement, the team proposed that the entire corner be manufactured as one unitized curtain wall panel, which in this revised detail pushes the slab edge and anchoring back away from the corner, allowing vertical continuity and seamlessness of the corners, as can be seen in the full-scale mock-up completed at BV Glazing's facilities. The same approach was taken on the north and south corners. In addition to the distinguishing design features of Sky Tower, there were special considerations that Pinnacle and the design teams collaborated on, particular to the design of a supertall. The Council on Tall Buildings and Urban Habitat, CTBUH, designates a supertall as being taller than 300 meters. Sky Tower as a 95-story tower was 294 meters tall to the top of the highest occupied floor. And when we added 10 floors, it became 335 meters tall to the highest occupied floor, crossing the threshold into becoming a supertall. And just for interest, these are the heights to the top of the parapet for 95 and 105, both of which are over 300 meters. In speaking with Jablonski Aston Partners, our structural engineer, we were told that the biggest challenge for supertalls is building slenderness, which is the height to width ratio. In order to address slenderness, the following strategies are applied in order of effectiveness: widening of base structure, lengthening of walls resisting the direction of slenderness, adding walls, and lastly, thickening walls. As our structure tapers down from the tower, given site constraints in building design, we were widening within limits and down to the levels of the podium, lengthened walls within these limits, and thickened walls where helpful. In order to deal with the lateral tension and compression loads in the wall, we needed to add post-tensioning to shear walls in the lower half of the building. Sleeving through post-tension shear walls would need to be minimal or avoided at all, as can be seen from the density of reinforcement. In the residential tower, this was not a problem, as shear walls are undisturbed between suites, using the corridors for mechanical transfers. However, when it came to the hotel suites, which were mechanically served by duct runs circling through the suites, sleeving through shear walls, this became a challenge. On the applicable levels, we were required to reroute mechanical ducts into the corridors to alleviate sleeving through or increase spacing between post-tensioning rods to allow for sleeving through the walls. While buildings of this height are designed to accommodate sway at the top, occupant comfort can suffer if not addressed. In collaboration with the team at Pinnacle, our structural engineer, wind engineer, and motioneering, who are world leaders in motion control solutions for tall buildings, we drew on past experience researching precedent tall buildings in New York City. Our engineers established the anticipated pressures and accelerations at the top of the building and used that data to tweak the structure. A design for supplemental damping was then provided by the team of engineers at Motioneering to reduce the acceleration to acceptable levels for occupant comfort. Based on previous project experience, Pinnacle asked the design team to consider the impacts of stack effect on stair design. We highlighted a conflict between the code requirement to passively pressurize the stair using stack effect and the anticipated pressures on doors at the top of the building. We turned to our wind engineers to model the wind pressures on crucial doors throughout the project. It was noted that stack effect pressures on stair doors from within the stair at the top of the building would exceed the allowable force to be applied to those doors for exiting as per the code. Effectively, you would need to apply above average strength to be able to exit into the stair, especially during a fire event. In order to address this on a day-to-day basis, we broke the stair stack into 4 sections by introducing vestibules in the stairs every 30 levels. However, during a fire event, the code requires all doors within the stair to open. So we're back where we started during a fire event with excessive pressures on doors at the top. In order to address pressures during a fire event, our mechanical design team, MV Shore, introduced pressure relief corridors to the exterior every 30 floors, controlled by pressure sensors in the stair, which would detect when air pressures are high and activate the relief louvers to allow air to dissipate to the exterior, equalizing the pressure within the stair so that doors at the top could still be opened from the floor area into the stair. Stack effect is not only an issue when it comes to stairs, it creates problems in tall buildings anytime air is allowed to communicate between vertical shafts in the building and to the exterior, especially when air infiltrates at the lower parts of the building in winter, affecting the upper sections of the building with outward pressures. Pinnacle took a strong approach towards mitigating stack effect, initiating and supporting comprehensive strategies to address this. We introduced interruptions in airflow between vertical shafts within the floor plates, as well as access to the outdoors. For example, on P2, we ensured that all elevator lobbies were partitioned into their own compartments with doors between them to prevent air from transferring back and forth between elevators. Of particular note, due to the height of the building and complexity of program, Sky Tower required 16 elevators. This creates a large number of vertical stacks that need to be considered for stack effect. On the ground floor, we made sure to separate each group of elevators into their own compartments and added several doors between those compartments and between elevator lobbies and exterior doors. Similarly for hotel elevators and the exterior. We also made use of 4-leaf revolving doors and vestibules for swing doors to limit airflow to elevator lobbies. On amenity floors, we turned low-rise and high-rise elevator doors away from one another into separate compartments, separated by 2 sets of doors in each direction to limit airflow between elevators and to the exterior outdoor amenity. On residential tower floors, we added doors between the elevator lobby and the rest of the corridor to prevent air from communicating between elevator shafts, stair shafts, and the exterior wall. The last level served for low-rise and the first level served for high-rise are 1 floor apart to avoid the 2 banks of elevators from being in the same air compartment. And at the top of the building in mechanical spaces, we added vestibules. Because of the height of the tower and the tapering at the top of the building, we asked Gradient to conduct a falling snow and ice assessment, which yielded that levels of snow accumulation at the top of the building should be addressed. Mullion caps and knife plates were recommended to be spaced along the facade every 500 millimeters on center to break up large accumulations. We continued to work with BV Glazing to develop the design of the knife profiles to a more minimal stainless steel blade, effective in meeting its aim but not impactful to the facade design. Lastly, we'd like to acknowledge that a project of this magnitude and complexity truly is a collaborative venture, and we wanted to thank the members of our strong and innovative team of experts who are bringing this project to fruition. Thank you.
Thank you, Nadine and Jody. The amount of detail is just amazing. The community that Urban Toronto has is fascinated by this kind of thing, and I think they're going to find just as fascinating a time now in our talk about Forma. Forma was originally known as Merge plus Gary Toronto when it was initially conceived as a 3-tower project replacing all of Ed Mirvish's restaurants and the Princess of Wales Theatre along the stretch of King Street West that lies either side of Duncan Street in downtown Toronto. Its trip through the planning process was an evolutionary one that saw the number of towers dropped to 2, while the Princess of Wales Theatre was saved. Mirvish still operates that theatre, as well as the Royal Alexandra Theatre that bookends the site to the east, but they sold the tower development to Great Gulf, Dream Unlimited, and Westdale Properties, after which the project was renamed Forma. Forma's east tower is the shorter of the two, and at 73 stories and 262.8 meters, not a super tall, but by no means short. When complete, the east tower will be less than 3 meters shorter than Frank Gehry's tallest building so far in New York City. Forma's taller sibling, however, the West Tower, will be the tallest Frank Gehry building when it tops out at 84 stories and 308 meters. While its suites have not gone to market yet, and there is no concrete timeline for it, the East Tower now features both a concrete timeline and concrete, as it is now rising on King Street across from Roy Thompson Hall. Sharing its design DNA with its super tall sibling to be, telling us much more about this celebrated development today will be Abel Gill, associate at Adamson Associates Architects. Abel joined Adamson's Toronto office in August 2007 and was made an associate with the firm in 2018. A graduate of the University of Waterloo, he brings decades of design and management experience to the team. His portfolio features work in a range of building typologies, including residential, sports, recreation, entertainment, hospitality, commercial, residential, and institutional, as well as transit facilities. And town planning projects. His dexterity in coordinating geometry and detail on projects featuring complex building envelopes has benefited Adamson's work on the Forma condominium towers, as well as subway stations at York University and in Vaughan. He also has had a key role in the Elizabeth Line's Canary Wharf Station project in London. Abel, take it away.
Thanks, Craig. Hello, I'm Abel Gill, associate at Adamson Associate Architects. I'm an envelope specialist here, and today I have the pleasure of presenting Forma by Frank Gehry on behalf of Great Gulf, Dream, Westdale, and our fantastic teams, RJC Facade, RJC Structural, Smith & Anderson, for mechanical and electrical, and we have Ellis Dawn on board, and our wall is being built by Firma Stelisa. So a little bit about Adamson Associates. Adamson was founded in 1934, so we've been around for quite a while. We have a wide range of projects, commercial, hotel, residential, what have you. The main office is here in Toronto. We have about 400 staff worldwide, our main office. The mothership is Toronto. Then we have offices in New York, Los Angeles, London, UK, and more recently, Vancouver. As architects of record, we've collaborated with a lot of great architects. Notably in New York, we've worked on the World Trade Center Tower 3 and 4. We've done the Hearst Tower in London. We have the Shard. In Toronto, there's a wide range of projects. There's a lot of hospital projects going on right now, but I'm quite pleased to be working on a Frank Gehry Tower right downtown, right next to Roy Thompson Hall. Our site is bound by the Princess of Wales Theatre and the Royal Alex, and Roy Thompson across the way. So here we can see the two plans where the towers straddle Ed Mirvish Way, which is now Duncan Street. The East Tower is right next to the Royal Alex, and this is the one currently under construction. As Greg pointed out, the West Tower will be adjacent to the Princess of Wales. So here's just a view of the tower from Roy Thompson Hall and looking towards Metro Hall there. And then just another view here through the streetscape on the left. You can see Princess of Wales. We have the Anderson facade, which is a historical facade that we'll be keeping with the West Tower. Then we have our East Tower and the Royal Alex in the far right. So the form of the tower, I'm sure many of you are aware, you know, it's been published quite a bit, like the early concept designs from 2013, when there were about 3 towers. It's now been, it's a 2-tower scheme currently. And the shorter one to the east. So with Frank Gehry's office, they always begin with the physical models, and the models are varying in scale. It starts with the tiny models, and they go version after version to validate design ideas. So as you can see, there are many iterations for the form of the towers here. Now, the current scheme, it was divided into 3 stacks to create some movement within the facade, but still have not totally bespoke floor plates everywhere. The facade itself is it's a stainless steel rain screen with 2 main cladding types: a shaped metal panel with a stainless steel rain screen, and then a more typical curtain wall. This is just an image of the stacking at grade. We've got some retail. There's some cultural space within the podium for the East Tower. And then you can see how the stacks work here. That, you know, from the podium, and then quite similar to the one at the mechanical floors, where we do the shift in the kind of change in geometry, the twist. We have what we've been calling the inset floor, belt floor, and typically on those floors we have mechanical. And then there's a crown feature at the top. Just some views. It's the important thing to notice also within Gehry's concept is that it really is about a two-tower scheme in terms of the overall presentation for how it inhabits the neighborhood. And, you know, very important is the relationship between the stacks between the 2 towers, how they relate to each other, and what they call the third figure, which is the space in between. So now, as a super tall, you know, we know that the views change from low to high, and Frank's office has done various studies from different levels to help inform how the twist happens within the stacks. So as you can see at these lower levels, the views are you know, obscured by the various other adjacent buildings, and as we move up, you know, it opens up more towards the water and the city as well. And then once we get up to at the 235-meter mark, we've got a pretty wide open view. So as you can see, these are the floor plates of the stacks. And then here we have some views to the city from different heights. And this is just another model of the current scheme. You can see the shaped metal panel, and then what we just called the flat glass. So very important to Frank's office is the facade. And we had 2 main approaches. As I said, we had the flat wall, and then what we have is the shaped metal panels, which is what we call the punch window. but it's essentially a curtain wall system with a rain screen. This diagram shows the kind of distribution and the geometry of how we've spread out the shaped metal panels in the sort of orange color and the flat glass in blue. And then their office did a lot of studies in terms of how to articulate the shaped metal. Playing with distances, how much deviation from our 0 point that we would do for to get a desired effect on the wall. So here, this one is at 250 mil. The previous one was 300. So it all starts with the physical model with Gary's office. And so they scan the physical model and then they translate it into digital project, which is based out of CATIA, to develop the panels. So creating movement within the shaped metal, it's quite an intricate study that they've done. It's, you know, to the eye, it may seem random or that you're not sure where it's repeating, but they've started with an original concept and modeled it, rendered it to see how the sun would reflect, and there wasn't quite enough movement, so they started adjusting the skin itself, introducing a micro texture to the facade itself. Within the punch window panels, this overall geometric strategies where one panel is sloping outward, one's flat, one's sloping inward. Same for the horizontal panels. And then we take those three basic moves, and then we introduce the kind of micro texture. And that was studies that were undertaken with physical models as well as computer models. You can see here, even though there's a lot of movement within this original scheme, it's still quite flat. And then introducing the micro texture to really pick up more light and animate the facade. The panels, it's quite a patchwork, and trying to sort it out it's pretty crazy. But let's just talk about Frank's office. When they're developing their models and studies on the facades, it always comes back to the physical, starting from small scale models to larger scale models. This was something that was built at their office to help validate what they had studied as within the 3D studies of the microtexture, just to ensure that it was achieving the desired effect. So with these physical models, you know, thinking about how the project is located within the city and views to certain landmarks within the city, they were validating their original mock-ups at their office from 10 meters, 50 meters, 100 meters. So you can see here, this is another mock-up made, and it's actually just paper with a silver foil on it to build these models. Frank is here, having a look at the panel, and then as you can see here, we're starting at probably 10, then we're backing up just to validate that you can see the movement for the materials. So the final materials, the stainless steel panel, it's not just a brushed stainless steel. We've gone with a linen finish because we felt that it helped dissipate light in a more pleasing manner. So this is the initial visual mock-ups that were built. These are actually stainless steel panels. And um, so it was important to go and see this, to see the physical visual mock-up, look at it closely, and to back up and to view it at different times of the day, because of the inherent to the material and the reflectivity. It really changes quite drastically over the course of a day. And just some other images here up close, viewing it from afar. And then, so next I'd just like to talk about how we were shaping these metal panels. There was a lot of rules to how many moves we would make on the sheet itself. And in essence, for all the technical advances, these are all, at the end of the day, are hand, every panel is hand bent on with a press. So we have about 7 moves that we can make in the panel. There's certain rules for the radius and how far to the next move. So here's some additional the studies that we were doing. These are in digital project, working out the framing with Perma, and these are the initial prototype panels. It's a surface mounted fixing that's visible, and we have our support ribs in the back. So here you can see our fine friends in Italy taking the sheets and beginning to form them. It's quite a little dance that they have to do with the panels as they form them, and it's really quite lovely. Here just an image of the press and custom made dies that we had for the various radii that we were using. This is an image of our backup structure, and here you can see panels that were made, and just there's a lot of variation, but there's a method to the madness for sure. And then one of the prototype panels, as you can see here, this was at the factory, and looking at it at grade, and then as we pull it up into the air, we can see how the material changes. Currently the project is we're up to level 5 or 6 on site. Panels are being fabricated, but we have gone through all our testing here in Scarborough at the UL Labs. So this is just a few images of our performance mock-up, where we pressurize the chamber. We're gonna rack this thing. We're gonna do vertical inner story movements. Here you can see we're setting up the propeller engines to do our dynamic tests. We do have operable windows. This is a residential building, and we've got a parallel opening window. And just some views, dimly lit, just to see how this is going to look in the evening. And I'd just like to finish off with some views, some renderings of the building within the city. And there it is. That's Forma in Toronto. I'm quite excited to be working on it, and quite privileged to be sharing this with everybody here, with my fellow colleagues and our friends at UrbanToronto. And thank you very much.
Thank you, Abel. All 3 presentations, pretty fascinating. So much going on. I am wondering, Earl, you mentioned that it's now 2028 completion for the one Bloor West, and I suppose that is for keys in everybody's hands, etc. Doors open to the various retail and restaurant establishments, etc. Before that happens for One Bloor West, and in the same cases for Pinnacle One Yonge Sky Tower and for Forma, um, buildings top off long before they're actually opened. And I'm wondering if the three of you can speak to any of the, Earl, if you can give a little bit more detail on any of the breakdown in the timelines that are coming up. And then Jody and Nadine, if you have any ideas of what the latest expectations are for Sky Tower in that regard, and Able for the East Tower at Forma, time-wise. Earl, can you break down a little bit more the steps before the 2028 completion?
I'd certainly love to be able to, but I think right now the schedule really still is under refinement by Tridel. And they've only recently taken over the project, and I think there's still a number of moving parts that we're trying to sort out before we get to that stage where a final schedule could be provided with respect to occupancy for the tenants as well as for the residents themselves. So that 2028 is a rough guideline right now in terms of expected completion date, and that's just relative to what we understand would be the normal course of construction based on where we are to date. But I think that's still, I think, Craig, a calendar really that still needs to be defined, so to speak.
Okay. And Jody, Nadine, what are the expectations for the Sky Tower at the moment?
Yeah, so what we've heard, and of course, as people have seen, Sky Tower has been quite ambitiously moving forward quite quickly. So topping off is meant to be sort of late fall or winter of 2025, so the end of this year in terms of the concrete. And then the date in 2026 has been floated for sort of being complete, but again, that's sort of just anecdotally. I'm not sure if that's a final number.
Okay, and Abel, I'm wondering in regards to Forma, do you have any indication of when that incredible cladding is expected to start on the building?
Um, it's coming soon. You know, currently we've probably poured up to level 6 or 7, the concretes. On the north side, some precast cladding has gone in. But the wonderful panels from our friends at Firma Stelisa, that's probably looking about fall. You know, I'm quite excited about it. I think it was going to be later, but apparently our concrete trades are doing fantastic, and they're moving ahead at a very good pace. So we're trying to bring up the when the first panels will come to site. I'm expecting fall.
Okay, thank you. We have one question at the moment from one of our viewers. They're interested in learning more about the environmental impact of Forma due to using stainless steel metal. Are you sure if there's, sorry, Abel, do you know any particulars in regards to environmental impact of stainless steel?
Uh, Honestly, I can't speak to that myself. I I don't know much about the impact of our cladding.
Okay, I'm not sure if our viewer is wondering if that means light bouncing or
Ah,
what. I suppose some of Frank Gehry's buildings have had to actually been decreased in reflectivity after they went up.
right.
Is that part of the micro surfacing?
Uh, the micro texture was creating to animate the facade, but definitely in the choice of material. You know, instead of a brushed stainless steel or definitely not a polished. Actually called it's a linen finish. It's an embossed finish. So it actually uh, really like dissipates the light. It's not as shiny as one would think being stainless steel.
Well, I know there's a lot of anticipation to see that actually apply to the building. For any of our viewers who have Further interest in these buildings, all of our projects come with threads dedicated to them. If you become a member of Urban Toronto, you can easily post in any of the threads, put forward your questions. There are a lot of very knowledgeable members there, and in fact, we can relay further questions to the architects if you have them later on. But I would encourage everybody to engage with Urban Toronto to find out more, and obviously keep up with construction of these towers as they go. And in the meantime, I'd really like to thank our 4 architects today for joining us and giving us a really in-depth look at all of these incredible buildings that are going up in the city now. So thank you to everyone. And I think we are just about to sign off. Anthony?
Yes, thank you, Craig. And with that, I'll echo your sentiments as well and thank all the presenters for joining us today. For all our viewers who are watching us live, thanks again for joining us today. I'd like to remind you again that you can visit www.thebuildingshow.com to learn more about this year's event, where Urban Toronto will also be presenting an in-person panel discussion. You can sign up for updates to learn about when registration launches. And with that, thank you again